In section 7.4, we're going to talk about what's called the remainder theorem and the factor theorem. We're going to use both of these kind of off and on to be able to solve different kinds of upper level kinds of equations. We have tools to be able to solve quadratic formula, completing the square. We know how to do that. But now we're going to kind of advance into problems that are even more difficult to be able to solve that won't work in either one of those ways. So let me remind you about something. Synthetic division. We've talked about this a little bit in the past. Let me kind of remind you of how it works. If I was doing this division problem, this is division. I'm taking the numerator, dividing by that. We could do long division, but this is easier to do by the synthetic division. The idea with synthetic division, you have to divide by something that's in the form of x minus a number. Now there's variations on a theme, but we're going to kind of stick to that, where it's x minus a number. So what I do is I take the coefficients of the numerator, the thing that's being divided, and I'm going to write them just without the variables. Then, again, it has to be in the form of x minus a number. So the number, in this case 2, goes in the little box over here. And then the pattern for synthetic division is this first number just comes down, and then you follow this same pattern every single time. You take this number times that number, and you write it in the next column. So 4 times 2 is 8, write it in the next column, and then you're going to add. Same pattern, take this number times that number, write it in the next column. 5 times 2 is 10, write it in the next column, add them up. This little line here is just telling you that this is the answer, that's the quotient when you divide, and this part then is the remainder. So just like when you do a division problem with numbers, sometimes you have a remainder. In this case, the remainder is 16. Now, here's the quotient, there's the remainder. Let me remind you about something when you do division. For example, if I had 7 over 3, 7 divided by 3, well, the answer is 2 with a remainder of 1. Look how you can write 7 over 3. That's the same thing as 2 1/3. By the way, when I say 2 1/3, it means 2 plus 1/3. So look at the remainder. The remainder ended up written as a fraction over the divisor, the number you were dividing. So I'm going to do the same thing here. I'm going to take the quotient, and then I'm going to take the remainder over the divisor and add it on to the end. So what I get then is this answer, this division problem, is that. X plus 5 plus 16 over x minus 2. So here's the aha moment that we're supposed to get. I'm going to take this same polynomial and I'm going to plug into, I'm going to find f of 2. Well, plug in 2, 2 squared is 4, 4 times 4 is 16, 3 times 2 is 6, subtract them, and I get 16, which, not coincidentally, is the remainder. That's what the remainder theorem says. When you take a polynomial and you divide by, using the synthetic division, when you divide by this number, or a number, sorry, the remainder that you get is going to be the same as if you put that number in to the polynomial. So let me show you an example. If I want to find what f of negative 3 is, I could just plug negative 3 into all of the x's and see what you get. And a lot of times that's easier. But you will get the same answer as if you do the synthetic division. So take the coefficients 1, 6, negative 1, negative 30, write them down. That's what's right here. I'm going to divide by negative 3. So follow the process like I did before. Bring down the 1. 1 times negative 3, write it in the next column, add them up. 3 times negative 3, add them up. Get negative 10. Negative 10 times negative 3, positive 30. And in this case, the remainder is 0. So if I were to plug negative 3 into this problem everywhere there's an x, the answer for that would be 0. So what's f of negative 3? 0. Same as the remainder down here. Now, kind of a related idea, look what happens in this particular case when the remainder is 0. If you do division, like if I take 6 divided by 2, well, that goes in 3 times. Sorry, that's a little cramped up there. That goes in 3 times. 3 times 2 is 6. Subtract, and you get a 0 remainder. And sure enough, 6 is equal to 2 times 3. 2 is one of the factors of 6. Because when you did the division, you got a remainder of 0. Well, what that means for us is, in this particular case, when I did the division and got a remainder of 0, I was dividing by, now remember, on this problem, the previous problem, when I had x equals -3, what I was really dividing by was x plus 3, because I was dividing by x minus -3. Remember, it has to be in the form of x minus something. So, because the remainder here is 0, what that means is that x minus -3 or x plus 3 is a factor. So when I was dividing by x minus 3 and I got a 0 remainder, then that means that x plus 3, and all you have to do is bring the x back, or sorry, the 3 back over to the other side. That means x plus 3 is a factor. So this original polynomial, I divided by x plus 3 and got an answer of, let me go back, remember, it's x squared plus 3x minus 10. That's the other factor. Just like if I take 6 divided by 2, right, and you get 3, when I get a remainder of 0, that means this is a factor, but that's the other factor. Those two things multiply together. So likewise here, these two things multiply together and give me this. Now in this particular case, and this is kind of what part of what this chapter is about, is recognizing that this quadratic can go even farther. This factors into x minus 2 and x plus 5. So the factors of this are all 3 of these. And it's not a coincidence that there are 3 of these, and this is an x to the 3rd power. Well, that's the idea of the remainder theorem and the factor theorem. The remainder theorem says when you do division by x minus 3, when you divide by minus 3, the remainder is what you would get if you plug -3 in. And the factor theorem says when you do the division and the remainder is equal to 0, that means the thing you divided by is a factor. So when I plugged -3 and did the division with the -3 back here and got a remainder of 0, since x equals -3, that means x plus 3 is a factor. Well, I hope that helped you out. And some things make sense. As always, come talk to me if I can help you out. If you need any help, rather.